Salam and hi everyone. Today we are going to present to you about occupational safety and health in laboratory. My name is Nur Azwarina binti Abdul Aziz and these are my members of Group 46. Our primary goal is to move beyond the book smart and develop situational awareness as visualizing the invisible, demonstrating the consequences, also simplifying for the complex law such as OSHA 1994 Section 24 duties of employees to students that is relatable in our presentation. So what made it unique is we are simulating high-risk scenario that is exposed as the video is allowed for safe exposure to extremely dangerous experiment. So the usefulness of this approach is to measure by how it changes behavior in lab that is useful in real-world application. Also standardize the training so that every student the exact same solution, ensuring no one get different safety advice. Most of the industry must follow the hierarchy of control principle so that when you see a hazard in a video or any industry, we are being trained to think in this order, which is identification of hazard, risk assessment, which is the solution, and also the control to make it prevent from the hazard. So without any further, let's move on to the video.
I'm gonna talk about the issue highlighted in the video. The hazard that happened in the video is negligence when operating a Bunsen burner. It can cause a fire or lead to inhalation of harmful gas because Bunsen burners typically use methane. The gas is flammable and hazardous if inhaled because it displaces oxygen and increases the risk of fire or explosion. So what is the solution for this? Firstly, we need to turn off the main gas valve, then we open the window. If the gas smell persists, immediately evacuate the room. Next, if there is a flame involved and it is not extinguished yet, remove flammable object away if you can and put it out using a fire extinguisher. And if someone get a burn, cool the affected area under running water for 10 to 20 minutes to minimize the skin damage. And how to prevent it from happening again? We can conduct a pre-operational check, provide proper supervision such as a lab assistant or lecturer to guide the student, and give safety training before the lab. Always light the match before turning on the gas. And lastly, install safety signs and reminders so that students did not forget anything.
As we can see in the video, hazard involved in this situation is a thermal burn hazard. This incident can occur when a student wears loose clothing, leaves long hair untied, or works too close to flammable substances such as ethanol vapor during an experiment. In the video, the student catches fire. The correct immediate action is stop, drop and roll to prevent the flames from spreading. A fire blanket should be used to smother the flames on the person. If available, the safety shower should be used immediately. A carbon dioxide fire extinguisher should not be used directly on a person's skin unless there is no other option. So, to prevent this type of accident, students must wear flame-resistant coats and ensure that long hair is tied back, and conduct high-risk experiment inside a fume hood with the sash fully lowered to act as a protective barrier. This safety practice is supported by the Fire Services Act 1988, which requires that appropriate firefighting equipment such as fire blanket and fire extinguishers are provided, accessible and properly maintained in high-risk areas like laboratories.
Why is his skin turning yellow? This is because the skin comes into contact with nitric acid, which is a highly corrosive chemical. This is a chemical hazard. So what is a chemical hazard? Chemical hazard refers to any chemical substance or chemical related activity that has the potential to cause harm to human properties and environment. When nitric acid touches the skin, it can cause a chemical burn and absorption. The yellow color seen on the skin is due to the acid react with the protein in the skin. This reaction is a clear warning sign that tissue damage is occurring. If this exposure happens, immediate action is required. The affected area must be flushed with running water at an emergency eye wash or safety shower for at least 15 minutes. Contaminated clothes should be removed and medical attention must be sought as soon as possible to prevent further injury. To prevent this hazard, we must apply the hierarchy of control, particularly personal protective equipment (PPE). Laboratory workers must wear chemical-resistant nitric glove, a lab coat, and appropriate eye protection. Concentration acid should never be handled without proper protection. From a legal perspective, the hazard is covered under USAC Regulation 2000, which is require employers and workers to implement control measures to keep chemical exposure below permissible exposure limit. Thank you. So, what is the problem in the video? And the hazard is, first, there are physical and reaction hazard. Second, a massive bench that lead to cross-contamination or accidental knocking over of the containers. And lastly, spill can react with each other to create toxic fume or fire, which is dangerous in laboratory. The solution for this problem is, first, you need to stop work immediately. Second, use a spill kit, which are neutralizer of air or any adsorbent to clean up the base on the chemical type. For the prevention, we must use 5S methodology, which is sort, set in order, shine, standardize, and sustain. It is also crucial to maintain a clear workspace where only the required apparatus is present on the workspace. OSHA 1994 general duties are used to maintaining a safe system of work include a tidy environment to prevent possible accidents. So what happened to the next video?
binti Nurul Hakim. Today I'm gonna present what are the hazards and the solution that are shown based on the animation before. So from the animation we know and see that the female student bringing in a lunchbox into the lab. So what are the hazards did it bring to her or him? The hazard is the ingestion or the internal poisoning that can happen to the people who are eating the food or drinking a drink inside the laboratory. So, this is because chemical in the air or on the bench can settle on the lunchbox or the food inside. Even a clean hand can transfer a visible toxin to the food. So, what are the solutions that can be applied to this hazard? We must keep the food and drinks outside the laboratory and also store them in the designated locker area. We can store our food and important equipment that we are not allowed to bring inside the laboratory inside the designated locker area outside the laboratory. So, what are the prevention steps that we have to enforce for the solutions? So we have to a total ban on food and drinks and even applying makeup inside the lab. Also apply a strict administrative control to all the lab users. So why do we have to follow all of these rules? USEC Regulatory 2000 Section 18 explicitly prohibited eating, drinking, or smoking in area where hazardous chemicals are present to prevent accidental indigestion. So, what are the conclusions to all of the hazards that are presented for our video today? In 2026, this scenario underscored that lab safety is a multifaceted discipline where behavioral discipline must intersect with regulatory compliance to prevent catastrophe failure, whether addressing chemical spills, fire emergency, or improper hygienes like bringing in food into the hazardous zones. The common thread is the necessity of the hierarchy of control, which prioritize elimination and engineering control, like fume hood, over mere reliance on PPE. Ultimately, adherence to the Occupational Safety and Health Act OSHA 1994 and the USEC Regulation 2000 provides a legal and ethical framework where maintaining a 5S, which will organize the environment and enforcing strict administrative bans on food, are not just rules, but critical life-saving interventions that uphold the student duty of care of themselves and others. So that's all from our group today. Thank you very much.